section is 2.8, multiplying and dividing mixed numbers. What you see on the board are 3 different sets of rules that are review. We've already talked about these. We've already worked in our study plan on them. The rules are multiplying fractions, dividing fractions, and changing mixed numbers into improper fractions. You have to know all of these rules to be able to do multiplying and dividing of mixed numbers. So if you need more time, you might want to pause the video so you can write down these rules to remind yourself. Otherwise, the video is moving on. The new rules for today, to multiply and divide mixed numbers, you will do number 1 for all of them that are not already in fraction form. And you will choose to do either 1 or number 2 on these rule list because it tells you which ones to follow. So for example, you're going to change number 1 says change each mixed number into an improper fraction, and then you would choose the first number 2 if it was a multiplication problem, or you would choose number 2, the division rule problem or part, if it was a division problem. So let's start with examples here. The first one is 2 1/2 times 3 1/5. First thing that we need to do is follow number 1. It says to change the mixed numbers into improper fractions. So we're going to use that backwards C method, right? We're going to multiply the denominator and the whole number together. So I have 2 times 2. I'm going to then add my numerator to it, and we're going to put this answer over the denominator that was already there. So 2 times 2 is 4. 4 plus 1 is 5, and so this became 5/2. Bring down the multiplication problem and do the same thing for the other side. 5 times 3 plus 1, 15 plus 1 is 16, so I got 16 over the denominator that was already there, which is over 5. Following the rules for multiplication, we can simplify in the diagonals or multiply straight across the top, straight across the bottom, and then we can simplify or divide at the end. But I'd like to do it now because they're small, very simple numbers to be seen here. Divide by 5 in both these diagonals and get 1 in both places. I can divide by 2 in both of these places, and I got 1 here and 8 up here. When I multiply across the top and across the bottom, I end up with 8/1, which is just 8. Final answer. Okay, let's try another one. I have 2 2/5 divided by 1 1/2. So I'm going to follow the backwards C, right? We did this little thing where you multiply and then you add. And so I have 5 times 2 plus 2, which gives me 12/5. Notice I brought down the division sign. I'm not changing anything yet. This is a common mistake for students. They just rewrite this as multiply. They change this as a backwards C, but they didn't actually find the inverse of it, right? The reciprocal, they don't flip it over. So be careful. This starts as division, and when you write these as improper fractions, it's still division. It's not time to follow those division rules yet. 2 times 1 plus 1. So I have 2 plus 1 is 3/2, right? That fraction division, or I'm sorry, the denominator that we already had. So now I have fractions, and it's a division problem, and I'm going to follow those division rules, and it's keep it, change it, flip it from this point. So change it to multiply and flip this over. I'm going to simplify in this diagonal. This is the only thing I can see that we can divide by, and this becomes 1, and this one becomes 4. I multiply across the top and across the bottom, and I get 8/5. This can be simplified. Remember, the numerator, the top number is bigger here, so I need to make this a division problem. It goes 1 time with a remainder of 3. So remember, the number on top is your whole number. The number on the bottom here is the remainder, which is the numerator, and it's over the number that was already the denominator. So this is over 5. So 1 3/5 is the final answer. What about 8 divided by 3 3/5? Well, I know what happens here, right? That backwards C, that multiplication and then addition. So I have 5 times 3 plus 3. So this is 15 plus 3 gives me 18 over the 5 that it started with. I know it's a division problem, but what about this guy? What is this? Right, I need it to be fractions for me to work this. And so I know a whole number is over 1 as a fraction. Now I'm at dividing fractions, so I'm going to keep it the same, change it to multiply, and flip this over. I'm going to simplify in the diagonal where I can, so I'm going to divide by 2 in both of these places, and I get 4 and I get 9. Okay. Multiply across the top and I get 4 times 5, across the bottom and I get 1 times 9, and I end up with 20 over 9. This cannot be my final answer because the numerator is bigger, right? So I need a mixed number final answer. So 20 divided by 9, and it goes 2 times, which is 18. I subtract and I get a remainder of 2. Remember that the numerator, that whole number is 2. The remainder, 2, is your numerator, and the number that was already your denominator will stay that denominator. That's where these numbers come from.